So what I did is I wanted to show the concept of protein synthesis, and I did it with Lego. I made a DNA strand out of the plastic tank tread, and showing all the parts of the DNA model, DNA molecule.
Cool.
And then that actually, then we showed them a model. I have a picture of it. It's not built anymore. But
maybe you can send that to me. I'll put it up.
Yeah, I have the pictures and everything. And, I also have one for photosynthesis as well.
Nice. Now, how long ago was that? Must have been a while.
2006.
Oh.
Yeah, 2006, 2007.
So this is 6 years you've been working Lego into the classroom.
Absolutely.
Cool.
Anyway, it was a car that just went back and forth like this, and there was a color sensor that read 2x4 blocks. You know, that was represented the DNA. And then once it read it, it would go ahead and take almost like a little finger, almost like a Pez dispenser, and the little pulleys that have the 6 holes in there. There were little pegs that were blue and gray that I could put in there in a certain sequence. That was kind of like the messenger RNA code. And based on where it slid out, you would read on a little basket underneath. There was disarticulated Lego minifigures. The head, the hair, the head, the torso, and the legs. And you would go ahead and spit it out, run down a little chain, dump out, and you would pick it up, look at it. There would be the codon and the anti-codon, and you would read which amino acid or Lego person part you got. You would pick it up, and then you got the whole sequence. You would go ahead and assemble a Lego person.
I think we must see this. Oh, it's not assembled anymore. Yeah. Well, I can't imagine. It was 6 years ago.
I made three of these.
Wow.
Okay. That was the type. That was point 1. Point 2 was a lot bigger. There was a guy that I knew who was in charge of Lego Science and LEUSD. I can't remember his name, and he loved it. And and the feedback that I got back at the time that I presented this, because I presented it to the classroom because everyone was giving their demo. I'm like, okay, this is mine. And I had it and everything. It was very, very different. I even had a little car which would transport it, as in like a chaperone protein. To the to the different parts of the organelles and then transport out. Anyway, point 2 was much bigger. It was on a track about this big, and the RNA polymerase, which is the thing that dispenses the little bricks, was much bigger and a lot more complicated. It would move real slow, and it had a little light sensor that read the DNA strand that was in there. And it worked like a Pez dispenser. There was a little armature that went back like this, and then once it got there, it would slide out the little 1x2 little thing, hit the little conveyor belt, go down there, and then you had a long bar of that was the messenger RNA, and you picked out the amino acid and put it in triplet codon sequence.
Now, totally, are you kidding? Playing with Legos in class?
Right. So, I had the DNA strand, and I can pull this apart and give it to them. Had every piece on there for DNA.
Awesome.
Well, and I made since that I made a smaller one of the same thing, where you could it was smaller and it did the same thing, but it could be built for an individual or a group. I also built one that showed a photosystem. Again, it didn't translate well. It worked pretty much like a Rube Goldberg model. It had a ball shooter with those little plastic balls that was basically an electron that would shoot it up. This is how a photosystem works. Shoot it up, it would act as electron, and it would go down the electron transport chain. And it went through these little gates that, as the ball moved, it would turn these little molecules. This is what it actually does. And then there was a weighted trap door. When the ball hit there, its weight allowed it to drop, and then triggered a light sensor that would work off a pneumatic piston that dropped these little balls. That was the proton pump that allowed the ATP to be made. And as it dumped down, it would trigger another thing that pulled the pin and allowed these two magnets to come together, which was ADP and phosphate to make ATP.
Cool.
And then the ball would just kind of go down this thing and put it back in. But it was also had a solar panel on there. So if I shined a light on it, a motor would go ahead and turn the crank and fire the ball. And it would work like this.
Cool.
Another one I did was, and this one didn't quite hit its target, but it still got me where I needed to go. I built it was basically a large chloroplast. And on top was the light reaction made out of white Legos. And on the bottom was the dark reaction made out of black Legos. And on top was two solar panels that you can actually turn to get to the right angle of the sun.
Cool. And
on one side you had 2x2 bricks. There's 3 of them that made carbon dioxide, carbon black, oxygen's blue, so it made like a little triangle. And there was 6 or 7 of them there. And then water on the other side. Oxygen, of course, is blue, hydrogen's red. And what you would do is you would go ahead and take the water one and you would split water. This is what you do in
How funny.
chloroplast. You split the water. The hydrogen goes in this one part where it uses friction to turn like a little wheel in there. And then parallel to that is a little ATP molecule. And what the hydrogen is doing is, of course, it's pushing the ATP down. And then the oxygen goes through this little conveyor belt, which is run by the solar panel. So as long as the light is on there, this little conveyor belt's running, and the oxygen goes in there and then goes out a waste basket because it's a waste product. And then as the ATP drops down, it hits a little lever that throws out carbon dioxide. And then you have a little tray in the middle. You take that carbon dioxide, you set it down there, you do this again until you build a 6-carbon sugar.
And I'll take your word for that.
Masterful.
I know.